Welcome viewers. In this video we will see the production of rotating magnetic field RMF in a synchronous motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic rotating magnetic field, how it is produced in synchronous motor. In order to know the working of synchronous motor, it is necessary that we know how a rotating magnetic field is produced in a stationary winding. The three-phase supply is given to the stationary winding. In that, how the rotating magnetic field is produced, we will see in this video. The rotating magnetic field is defined as a field or flux having constant magnitude but whose axis rotate in a plane at a certain speed called a synchronous speed. So the axis is rotating continuously with a constant speed called synchronous speed. So we'll see that how it is rotating with the help of phasor diagram. We'll see that. So the RMF can be produced in two ways. One is by physically rotating the field winding. Second one by giving a three-phase AC supply to the stationary three-phase winding. So in the synchronous motor we are using the second method. Three-phase supply is given to the stationary winding. In that rotating magnetic field is produced. So let us see how a rotating magnetic field is produced in a stationary three-phase winding when three-phase supply is given. Right? So the second method is applicable for the synchronous motor. We will see how it is produced, how the rotating magnetic field is produced when the stationary three-phase winding is given with the three-phase AC supply. So the production of rotating magnetic field RMF. The three-phase stationary armature windings are RYB. Three-phase windings are displaced from each other by an angle 120 degree. We know that the three-phase windings are available. This RYB. The three-phase mean we know that this is displaced by 120 degree. There are total 360 degree. Three phases, 360 by 3, 120 degree. So each phase is displaced by 120 degree. When three-phase supply is given to the three-phase winding, current flows through all the three phases, which will also displaced by in phase by 120 degree, right? So when the current is flowing through that, the current also displaced by 120 degree. So this is the three phases R, Y, B. R and Y is displaced by 120 degree. Y and B is displaced by 120 degree. B and R is displaced by another 120 degree. So total 360 degree. So when the current is flows, that also displaced by 120 degree. The current are IR, IY, IB. Now we'll see the equation for that. So IR equal to IM sin theta, because we'll say IR is the, we'll take it as reference 0 degree. IM is nothing but maximum value. So IY equal to IM sin theta minus 120 degree. So there is a phase displacement of 120 degree. Here 120 degree is there between R and Y. So it is minus 120 degree. And IB equal to IM sin theta minus 240 degree. So while taking R as a reference, that phase displacement between R and B is 120 plus 120, 240 degree. So between Y and B 120 degree, but between R and B there will be 120 plus 120, 240 degree. So we'll take RY as a reference. So between R and Y 120 degree, between R and B 120 plus 120, 240 degree. So this is the current equation. For IR sin theta, IY sin theta minus 120 degree, IB sin theta minus 240 degree. Right. Now we'll see how the fluxes are produced. These current produces a flux in all these winding, which will be in phase with the current, but they will also displace from each other by an angle of 120 degree. So when this current is flowing through the winding, it will produce the flux that is in phase with the current, but all displaced with each other by 120 degree. So that we'll see the diagram. So this is the diagram. So pi R, pi Y, pi B. So R phase, Y phase, B phase. The current IR flowing through the R phase, so the flux pi R is produced. Pi Y and pi B. That also displaced by 120 degree. That equation we can write pi R equal to pi M sin theta taken as reference. Pi Y equal to pi M sin theta minus 120 degree. Between R and Y there is a phase displacement of 120 degree. Pi B equal to pi M sin theta minus 240 degree. Between R and B 120 plus 120 240 degree phase difference will be there between R and B. Either minus 120 or minus 240. So the pi M is nothing but maximum value of the flux. So the total flux is nothing but pi R plus pi Y plus pi B. By adding these three, we'll get the maximum, the total flux. Now we'll see the waveform. So the waveform for these three fluxes can be drawn as the sequence is RYB. We know that pi R will start at the start first. Then pi Y will start after 120 degree from pi R, because there is a phase displacement of R and Y is 120 degree. Then pi B will start 240 degree between R and B after pi R, right? So the angle between R and B is 120 plus 120, 240 degree. So pi R will start at 0 degree, pi Y will start at 120 degree, pi B will start at 240 degree. So based on that, we'll see the waveform. So the x-axis time period is there, is a flux. We are drawing the variation of flux. So 0 degree. At 0 degree, the flux in the R phase starts, pi R. So after 120 degree at this point, this is the 1 is 0 degree, 2 is 60 degree, 3 is 120 degree, 4 is 180 degree. So at position 2, 60 degree. At position 3, 120 degree, the pi Y, the flux in the Y phase starts. In position 4, this 180 degree. At 180 degree, no, this 240 degree. Now position 4 is 120. At 180, at this position 5, 240 degree, the pi B will starts. So pi R starts 0 degree, pi Y starts 120 degree, pi B starts 240 degree. So the total flux is sum of these three. Now we'll see the vector diagram. So we are going to see the flux value for this 4 position. Position 1, 0 degree. Position 2, 60 degree. Position 3, 180 degree, 120 degree. Position 4, 180 degree. For these 4 positions, we are going to see the phasor diagram. Thereby, we are going to analyze what is the total flux. So let us find the value of flux at the position 1, 2, 3, 4. That is 0 degree, 60 degree, 120 degree and 180 degree. Now we'll see the flux values. So this is the flux pi R, pi Y, that is 120 degree. Another 120 degree we have pi B, right? 0 degree, 120 degree pi Y, another 120 degree pi B. The negative drawn as dotted lines minus pi R. Pi Y negative drawn dotted lines minus pi Y. Pi B negative opposite side minus pi B. Right? So R, Y, B. Similarly we have minus R, minus Y, minus B. So this is the position 1. At the position 0 degree. Only we have pi B and minus pi Y. The position 1. This is position 2, plus pi R and minus pi Y. So position 3, plus pi R and minus pi B. So position 4, minus pi B and plus pi Y. So based on that, we are going to see the all 4 positions, right? So this is the position 1, 0 degree, position 2, 60 degree, position 3, 120 degree, position 4, 180 degree, right? This now we'll see this position one by one. First we will see the position 1, that is at theta equal to 0 degree. First we will see the flux in the 3 phases. Pi R equal to pi M sin theta. So theta is 0. So pi M sin 0. So totally it is 0. Pi Y equal to pi M sin theta minus 120 degree. So 0 minus 120 degree. So that pi M sin minus 120 degree. So that value is minus 0.866 pi m. Then pi b equal to pi m sine theta minus 240. Theta is 0, so minus 240. So that value is 0.866 pi m. So pi r equal to 0, pi y is negative minus 0.866 pi m, pi b is positive 0.866 pi m. So based on that we can go for the vector diagram. Now we'll see the waveform so that we are able to understand what is the position available in the theta equal to 0, what is the position 1, or how the values are decided. Now we'll see the waveform. So this is the waveform what we already discussed. See, this is a position 1, 0 degree. So at 0 degree this pi r value is 0. Pi r value is 0. This is positive. What is this? This is nothing but pi b. Pi b is positive. And this value is negative. What is pi y? Pi y is negative. Pi r is 0. Pi b is positive. Pi y is negative. That is the thing what we got in the while substituting theta equal to 0. Similarly, we will see the phasor diagram. So this is a phasor diagram. R, Y, B displaced at 120 degree. Then we drawn the negative values, minus pi r, minus pi b, minus pi y. So everything is now displaced by 60 degree. So this is the 0 position. Here pi r is 0, positive pi b, negative pi y, plus pi b and minus pi y, what we discussed in the position 1. In position 1 what we are getting, this pi r is not available, pi b is positive, pi y is negative. This is position 2, this is position 3, this is position 4. So in position 1 plus pi b minus pi y, in position 2 minus pi y plus pi r, like that it will go. Now we'll go to the position 1. Now we'll see this vector diagram what we discussed in the waveform. So this is the position 1, plus pi b minus pi y. Pi r is 0. So it is represented as 0, A, B and C. It's the total. Pi t is the total flux. Here one perpendicular line is drawn, that is point D. The point D, that is exactly the bisector. These distances are equal. So the resultant pi t is OC. Drop a perpendicular bisector AD to OC. So that OD equal to DC equal to pi t divided by 2. This OD is equal to DC. This bisector, so both are equal. That value is pi t divided by 2. Right? So this is the position 1. Now we'll from this angle OAD. This is OAD. Now we are going to refer this triangle. This angle is 30 degree. OAD. This value is pi t divided by 2. This value is 0.866 pi m. Right. Now from that we are going to find the cos theta value. Cos theta. Cos theta is adjacent side by hypotenuse. This is the opposite side. Adjacent side hypotenuse. So adjacent side by hypotenuse. OD divided by OA. OD divided by OA. So OD is nothing but pi t divided by 2. Already discussed. Pi OD equal to pi t divided by 2. OA is nothing but 0.866 pi m. So that is equal to this 2 is brought to denominator. So the pi t divided by 2 into 0.866 pi m. Now we'll go for the further simplification. This cos 30 equal to pi t divided by 2 into 0.866 pi m. This cos 30 degree is nothing but 0.866. So that value is substituted. Now cross multiply. Brought all this value this side. So that this 0.866 into 2 into 0.86 pi m equal to pi t. So by simplifying this, what we got? 1.5. 1.5 pi m equal to pi t. So that pi t equal to 1.5 pi m. So total flux equal to 1 times of maximum flux. So at position 1 we are getting 1.5 times of maximum flux. The magnitude is 1.5 pi m and it is pointed vertically upwards. So they already discussed in the vector diagram. It is vertically upwards. Now we'll see the position 2. So at position 2, theta equal to 60 degree. Pi y equal to pi m sin theta. Theta is 60 degree. So sin 60 is nothing but 0.866 pi m. Pi y equal to pi m sin theta minus 120 degree. Theta is 60. So 60 minus 120 is minus 60 degree. So sin minus 60 is minus 0.866 pi m. Then pi b equal to pi m sin theta minus 240. That is 60 minus 240 is minus 180. So sin minus 180 is 0. So pi r is positive value 0.866 pi m. Pi y is negative value minus 0.866 pi m. Pi b is 0. So that thing what we already discussed in the waveform and vector diagram. Now so based on this value we will see the vector diagram. So this is point O. See, this is OA is pi r 0.86 is pi m. Then pi y minus 0.866 pi m. So this is the resultant vector O A B C, right? OA is pi r positive, OB is negative minus pi y, OC is resultant flux pi t. So similarly here also we are dropping perpendicular line, that is a bisector OD equal to DC, right? That is equal to pi by 2, very similar to previous case, pi by 2. This OD is equal to DC equal to pi by 2. Now from this triangle, now we consider the triangle OAD. This angle is 30 degree. We are going to find the cos 30 degree equal to, we know that this is adjacent side by hypotenuse. This is opposite side, adjacent side, hypotenuse. Adjacent side is OD divided by OA. OD already we know that OD is pi t divided by 2. OA is nothing but 0.866 pi m. Right, this 2 is brought in the denominator. So 2 into 0.866 pi m. I will go for the further simplification. Cos 30 equal to pi t divided by 2 into 0.866 pi m. We know that cos 30 is 0.866, that is equal to this value. Now cross multiply this. So that what we got, 0.866 into 0.866 into 2 into pi m equal to pi t. While simplifying, what we got, 1.5 pi m equal to pi t. So the resultant flux equal to 1.5 times of pi m. Very similar to the previous case, but the position is different. So the magnitude is 1.5 times of maximum flux, but the vector is rotated in phase from the initial position by an angle of 60 degree. So that is we already discussed, right? So the value will be max same, but it is rotating. The field is magnetic field is rotating. That's why it is called rotating magnetic field. So in previous case 0 degree, so vertical is there. Now it is rotated with an angle of 60 degree, but the value is remains same, 1.5 pi m. Now we'll go to the position 3. So at position 3, theta equal to 120 degree. Now we'll substitute this value. Pi r equal to pi m sin theta. Theta is 120 degree. So sin 120 is nothing but 0.866 pi m. Then pi y equal to pi m sin theta minus 120. That is 120 minus 120. So it becomes 0. Sin 0 is 0. Then pi b is pi m sin theta minus 240. So 120 minus 240 is minus 120. So sin minus 120 is minus 0.866 into pi m. So pi r value is positive 0.866 pi m. Pi y is 0. Pi b is negative minus 0.866 pi m. So based on that we will see the vector diagram. So this is point O, A, OB and OC. So OA is pi r, positive value 0.866 pi m. OB is negative value minus 0.866 pi m. This is a resultant vector, resultant flux. So here also we drop a perpendicular line to OC so that it cuts at D. So OD is equal to DC, that is equal to pi t divided by 2. So this is a position 3 we already discussed in the vector diagram. Pi b and pi r is available, pi y is 0. So now we consider this triangle OAD, this triangle with angle 30 degree. This is opposite side, adjacent side and hypotenuse. So we are going to find the cos theta, cos 30 degree. Adjacent side OD divided by hypotenuse OA. We know that this OD is nothing but pi t divided by 2, bisector. And OA is nothing but this pi r value, 0.866 pi m. So it is pi t divided by 2 into 0.866 pi m. I will go for the further simplification. So cos 30 equal to pi t divided by 2 into 0.866 pi m. We know that cos 30 is 0.866. Now cross multiply this. So that 0.866 into 2 into 0.866 pi m equal to pi t. So while simplifying, 1.5 pi m equal to pi t. We can write pi t equal to 1.5 times of pi m. So the resultant flux equal to 1.5 times of pi m. Very similar to position 1 and position 2. In position 1 and 2 also we got 1.5 time, but it is rotated. Magnitude is 1.5 pi m, but the vector is rotated again by in space of 60 degree. Initially 0, in position 2 rotated by 60 degree, in position 3 thereby rotated by another 60 degree. That's why it is called a rotating magnetic field. This axis is keep on rotating. Now we'll see the position 4. So at position 4, theta equal to 180 degree. So pi r equal to pi m sin theta, that is pi m sin 180. Sin 180 is 0 degree. 0. Pi y equal to pi m sin theta minus 120 degree. That is 180 minus 120 degree. 60 degree. Sin 60 is 0.866 pi m. Pi b is pi m sin theta minus 240. So 180 minus 240 minus 60 degree. Sin minus 60 degree is minus 0.866 pi m. So pi r is 0, pi y is positive, pi b is negative. I will see the vector diagram. So this point A, O. So this again another rotated by 60 degrees. So is OB, OA, the resultant flux OT, OC. So this OA is pi y 0.866 pi m. OB is pi b minus 0.866 pi m. So here also we have dropped the perpendicular line. So it intersect at D, that is a bisector. OD equal to DC equal to pi t divided by 2. The total value is pi t, is the half of the value is pi t divided by 2. So now we consider this triangle OAD. This angle is 30 degree. So this is opposite side, this is adjacent side, this is hypotenuse. So cos 30 is adjacent side, OD divided by OA. So cos 30 equal to OD divided by OA. OD is nothing but bisector, pi t divided by 2. OA is 0.866 pi m. So that is this 2 will come in the denominator. Pi t divided by 2 into 0.866 pi m. I will go for the further simplification. Cos 30 equal to pi t divided by 2 into 0.866 pi m. Cos 30 is 0.866. Now we will cross multiply this. Then we will simplify so that we got 1.5 pi m equal to pi t. That is pi t equal to 1.5 times of pi m. Resultant flux equal to 1.5 times of maximum flux. So here also we got the same value, but it is rotated by another 60 degree. So the magnitude is 1.5 pi m, but the vector is rotated again in space by 60 degree. So it is keep on rotating, that's why it's called a rotating magnetic flux. It is seen from all 4 states that the magnitude of resultant flux is constant, 1.5 times of maximum flux. But it keeps rotating in the phase, 60 degree. It's rotating by every 60 degree. The speed at which this flux is rotating is synchronous speed, ns equal to 120 f by p. So the flux is constant, but it is rotating. The speed is ns 120 f by p. So in this video we discuss about rotating magnetic field in a synchronous motor. We discuss all 4 positions with a vector diagram and resultant value. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.